All right, welcome everybody. Tonight is the 2nd of November in Dallas, and this is Dallas Personal Robotics Group. We each Tuesday night have a meeting where we go around the table and talk about the robots that we've been working on or ideas we found and whatever other random things seem to fit the topic. So we're going to follow that model tonight. And well, without further ado, we will get an update first from Murray in New Zealand, and then I will give something, and then David Anderson, then Doug P., and then whoever else is next will be next. So, Mr. Murray, what have you got?
Hello. Over on the Personal Robotics chat board on Discord, we have a project that John of your group has been wanting for a while, and it's actually in motion now. We've got a guy in upstate New York and one guy from Seattle from, I believe, the Seattle Robotics Group. And I can't give names because that's giving people's names away. I could give the handles on, but it doesn't really matter. Point is there's 4 of us. And we've got one guy, Alexander, in upstate New York, who is working on the RP2040 C and C sharp, or not C sharp, C++ motor controller code, and has also contributed the motor controller schematic. And this is a 5 amp per channel I2C motor controller. And so he's done the basic schematic of the motor controller and the RP2040 side of things. And John is working on the KiCad conversion of that into a KiCad file, which will probably end up going to Easy EDA for the actual build. We're going to have a USB connector on there so that it can be reprogrammed. And of course, for all those who have been following my progress, or desires anyway, I've been trying to get an I2C slave in MicroPython for well over a year, and this is actually looking to happen. The guy that we've got from Seattle, Adam, who's jumped in, he's actually read cover to cover the entire RP2040 spec, and he's fairly confident that he'll be able to provide a MicroPython implementation to effectively replace the C++ one that would be the default. So we have a fallback, which is the one that will be delivered quickly. But if he's capable of creating the MicroPython version, I would effectively be charged with writing the actual library to support that on the client. So basically a client library. And it turns out the board's turning quite interesting because it'll be both delivered as a C++ Arduino style code, but it will be reprogrammable in MicroPython, and it will have encoder support on board using the PIO part of the RP2040. So and according to Adam, I can't remember the numbers, but the PIO can easily, he was saying, I can't remember, it was 12 megahertz or something. Put it this way, there's not an encoder on the planet that could overrun this thing. It's got plenty of performance. And so we'll have 2-language implementation. It's going to have a USB port for reprogramming. It'll have extra pins broken out onto the board so you can solder up some sensors or whatever. It'll have the ability to have the onboard, in the MicroPython side of things, it'll have the PID controller on the board if you like, as well as encoder support. This is 5 amps per channel, and the whole project is going to be open source. So I think our target price is something around $20 a board to have it built for us, out of JCLCPD, whatever. I can never remember that acronym. But in any case, the project's coming along, and I'm probably going to be the slow one because this month of November for me is shot in terms of schedule. But it's coming along, and I don't see any particular barriers. According to Adam, he sees the RP2040 as a real possibility for an I2C slave implementation in MicroPython, which would be, apart from the STM32, the only other one that we've seen anywhere. I think that the Teensy may be able to, but I haven't actually found any implementation of that yet. But the project's coming along, and we're hoping, I don't know if it'd be before Christmas, that we'd actually have a running version of it on a board. But it seems like there's a fair bit of kind of oomph and momentum in the chat right now, and like they're just back and forth today talking about the PC board and the versions that John's posted in KiCad. And so I'm quite optimistic about that project actually coming to a finish maybe this year. And apart from that, I am, there's nothing much to report on my Python OS. I basically made some mistakes in how I was doing the motor directives. Basically, I send messages around on my message bus, and the message contains an event type, like let's say, move forward at half speed or whatever. And I've made the payload on those messages able to handle a direction enumerator or enumeration, a speed enumeration, so you can have the standard Chadburn, half full, dead slow, the kind of things you'd see on the old ships. So those can be sent as directives to the motor controller, and you can say ahead or astern, and dead ahead, half speed, kind of thing, just like a ship. And there's no point in passing around numbers, really. I mean, on a robot like this, saying I want to go at 30% or 35% or whatever, it doesn't mean anything. It's like you're either going dead slow because you're crawling up to something, or you're going, a third or a half or whatever. So I'm just kind of passing those messages around. And I was doing it all wrong. So I'm just rewriting that now and kind of getting there. And I keep putting off this idea that I was going to do a demo video or something, but I just haven't had the time, frankly. So apart from that, I think everything else is, that's about it from here. Done. I tried to talk as long as possible, Carl.
Hey, no problem. As you may have noticed, I actually had time for another scoop of ice cream or two. So,
Carl, if I could interrupt, I
Sure.
noticed that Mr. Merriam has joined us. Arud, are you there? So we have a new participant this evening.
I thought
I had actually twisted his arm to try to get him to come. So,
Oh, good job. I thought we've seen his name before, but if first time welcome, that's great.
there he is.
Hi, yeah.
Good, your
Okay.
mic is muted. Good, your mic is muted.
Audio's not working, Rude.
Okay, let's try it with turning the microphone on. Does that
That
Hey.
works. Hey, amazing.
Presto.
Well, great to see you here.
Yeah. Got a nudge from David to come by and join and see what was going on. So thought I'd follow up on it and see what happens.
Welcome. Well, hopefully we have enough interesting things to catch your attention.
So everybody be on good behavior.
I'm gonna blank my video again because I'm eating supper and I don't want to look like a slob here.
No problem.
Paying attention.
Yeah, and do know that we do record these things. So if you don't want to be recorded, put a note in Slack and we'll turn it off, or just don't say anything. But either way,
I don't care about the recording.
okay. Most of it, we're all in the same category, so good deal. Okay.
Here, paying attention.
No worries. Well, with that, then I'm going to jump right in. Again, I'm next, and I think David Anderson and Doug Paradis. So I'm going to show. I actually did something related to robots this last week, remarkably. Although when you see what it is, I don't know if the word "remarkable" is really worth using like that. But basically, what I did was, and let me change the camera. Oops, not that way. So there's a little backstory to this. I have some cousins or nephews, or a mix of that, who are 10. And I bought for them, each of them, an M block STEM robot, 60 or 80 bucks. It's a kind of nice little deal. It's all connectorized and it's got no encoders, but it's got a nice set of different options and things. And I printed up this kind of sumo course, and we each have a copy so they can practice in their own homes. And so this Halloween, the other day, we tried to get them together so we could have our first little sumo battle. So of course, I thought it was Halloween, so I had to do something special with mine. So we'll come back to it in a minute. But it's got your basic basic behaviors here, for STEM robots. So hit the button to get it started. It looks around, it sees something, and it sees the tripod. So it's a little too close to the edge of the world there. But if we get it out, so it seems to work okay.
It sees something and goes straight through it.
Say what?
No, you said it sees something, and I said, well, and it decides to go straight through it.
That's right. That's right. So, anyhow, it's not that much of a demo, but I thought that I would show some interesting things under the covers. And the first thing I'll share is on the decoration. So that little beat that I put in the front, and we'll come back to that in a minute because it's amusing in its own right. Why is it flashing? That's not good. Okay, now it's not flashing. Okay, so it started life as this $3 plastic cup from Walmart. And, a regular old hacksaw took the back off, so that's cool. And then I thought, well, how am I going to cut off the rest of it? So, I had these two different tools, and I'd try. Anybody care to guess as to which tool worked better than the other? No guesses. We'll come back.
The Dremel is my guess.
Okay, Kareem would guess the Dremel, and that would not be right because it didn't have enough clearance. And then there's another problem that was amusing. So anyhow, a hacksaw got it this far, and then this thing let me take off. The blade was thin enough that I could cut out the base, so it got it to this point. And but that's still, it needs to get more compact. So get out the ruler. It's got to have the jaw cut off so that the the IR sensors can have clearance. And skill saw, which worked good before. Does anybody see a problem with this?
It's just, that's real.
It just melts.
That's real common. It just melts and reforms behind
Yeah.
it.
Yeah. So I took all the time to go all the way through the jawline, and then the piece didn't fall off, and I looked, and it glued itself back together again. So
Yep.
yeah,
Yeah.
live and learn. All right. So, it's all about STEM. So I thought I'd try this tool. Why not try this tool? What could go wrong? Okay. So Kareem's laughing. David's
Those don't
laughing.
dissipate heat at all.
Yeah. So, all right. Well, it was fun. to try.
Bandsaw would work best.
But it did give a nice extra decoration to the jawline because there wasn't enough clearance to get it past the arm, so it wasn't even going straight. But it didn't matter because it glued it back, and it adds more character to the decrepit face. And so at the end of the day, what worked well was not a bandsaw but a hacksaw, and that got that there, and then opened up the eyes with a growing set of drill bits, and then I didn't have a big enough bit, so this grinder worked pretty well. And well, anyhow, so that was that. But the next little bit about the construction is something I wanted to share. So, for years now, I've been hearing the word subsumption architecture, right? Subsumption architecture. And I thought, how simple can I make something and still have it formally be classified as a subsumption architecture? So, I have this little block diagram, and it's not into subsumption yet, but it's actually kind of cool. I have to say, the Scratch language, it's visual. It's not rich enough, so you don't want to do anything too serious. But, when it starts up, I initialize stuff. I have a block like that. Then forever, it'll just check these buttons. And if those are pressed, it'll go in the right mode. Otherwise, it'll let you drive around. So, okay. Just interrupt me anytime if you have questions. This is really complicated stuff here. And then the top level of sumo fight mode. All right. So, you enter in the mode, you want to start off clean. So I initialize. And when you leave it, you want to put things back in order. So I initialize again. But in the middle, it just repeats until you push the button. C means stop. And it has these two parts. It has sample sensors and compute behavior requests, and then arbitrate behavior requests and perform highest priority behavior. So I don't know if I'm following the rules on this or not yet, but if we drill into that, here's the highly evolved arbitrate behavior construct. So If the mode request is to escape, then we'll escape. Otherwise, if the mode request is to push the enemy bot, so it'll go forward. Otherwise, it does this. So I figure that because it's just going through this, sampling the sensors and doing this arbitration, in a way, the escape behavior will subsume the push forward, and the push forward will subsume the other one. So I figured maybe this counts, maybe not. I don't know. And then this is really so fasten your seatbelts because we're going to look at the mode for push enemy bot forward. Anybody want to care to guess how complicated it is? Okay, that's it. And then the other behavior we have is find enemy bot. Let's look at that one. Okay, so anyhow, and then the escape behavior. This is absolutely ballistic, but you know, it just it's kind of fancy enough that if both sensors, if it hits the line square on, then it backs up straight. If it hits one or the other, then it backs and turns one way or the other. But and then sampling sensors, so it just sets flags. And anyhow, so that's all I had to do. And that's so my question is, in the world of subsumption architectures, is this about as simple as you can get? Does it count? Is it too trivially simple and I should just go away?
Looks like subsumption to me.
Woohoo! All right. Okay, so I finally caught up with the subsumption architecture, and I can actually.
And Carl, I wrote it in the same language which you did.
You did?
In the same language which you did with the things which you
Scratch
kind of language. That's what I wrote my first subsumption too.
Kumar, this is awesome. This is why we went. What level degree did you get, Kumar?
I had just one behavior, which is light is there, high priority, do something, no light, just keep moving forward. But the language in which I wrote is exactly the language which you used, which is Scratch. And I said, why do I need anything more complicated like interrupt driven or anything? It's just a prioritization of behaviors. I did exactly what you did on my cute bot, which is the itsy bitsy robot, which I had sent a video across to some people, but that's what I did.
I think, Kumar, I should just give up now.
Give up on?
Yeah, give up all this Python crap I've been doing for the last few years. Ridiculous.
And if I may add to that, one of the things which Maria mentioned is you have a behavior and you have a counter behavior, and they need to be in back with one another. So
that was David's idea, having two in counterpose to each other that kind of balance.
And then the next behavior which I was trying to implement was go search this cone. And then I said, if I don't have a counterpose behavior, I'll go and crash into the cone. So the counterpose behavior is when this cone becomes very close to me, stop. So I don't know whether that's also subsumption and counterpose as in subsumption. But since we brought up this discussion, I thought I'll just raise it over here.
Well, this might be a good time to invite our guests to talk to us about B trees, because I think that they solve the same problem.
Okay, let's do that. But before we leave this topic, there's one question that nobody's asked. So go ahead, Rude. B trees. If you on demand, if you want. I mean, just.
I'll ask the question first, Carl. Did it work?
Oh, it worked great, but the president of DPRG did not win any of the bouts. Can anybody
Not a
guess?
one?
His nephew, well, actually, his nephew's dad, who's a software QA for American Airlines, kind of, it didn't have as good of an algorithm. It wasn't as robust, but pushed it out of the ring every time. Can anybody understand or imagine why the other robot might have done that?
I'm sure they got underneath your front there.
Not too bad of a guess, but it turns out that this piece of plastic is actually relatively heavy. And it was only after I spent 2.5 hours throwing chunks of plastic into my safety glasses that I realized that I was putting a whole bunch of weight on the front wheel and relieving the weight from the traction wheels. So this thing would turn around and find the robot and start to move, and then his would eventually figure out and just push forward and knock me out of the ring. So, Okay, so anyhow, that's my, I don't know what the story means, but it was kind of sad and funny all at once.
You know, Carl, in the big league subsumption, they use vacuum cleaners to suck the robot down to the floor and keep it from make it hard to push.
Yeah,
That's all you need is a vacuum cleaner.
vacuum cleaner. Yep.
I was going to suggest that the front of the robot having a slope on it pushes it down also on the front. There's a little bit of slope on your front end.
Mm.
I muted you, David. We're getting tons of reverb from your microphone.
Me, Dave?
Yeah.
My mic is turned on. My mic was turned off during the.
Okay, well, anyhow, so there's a request for bee trees, which I barely remember from undergraduate days and haven't really seen since. But Rud, will you accept David's challenge and share some thoughts on bee trees? Audio.
And you'll need to unmute.
What you're remembering from undergrad may be what you're thinking of binary trees, not to be confused with what I have been working with called behavior trees.
Oh, behavior trees. Yeah, I was thinking of the data structure.
Right. And it's a little bit difficult to explain without a whole bunch of diagrams. So I'll do what I can on here. To start with, of course, with any type of tree, you have a leaf node. And a leaf node is something in a behavior tree that takes an action. So if you, that's your actual behavior or your task that's going to execute. Change values, cause the motors to move, cause a hand to move, whatever. And so those are generally called actions. Then you have trees above that, which you start with of course, a main node, a starting point. And then there's two sets of sequences of action that could happen. One is it starts out and it proceeds through that set of tasks, which if any of them return true or active, then the whole sequence then returns up to the top level and comes up one level. The other set of sequences basically all of the actions, all of the nodes must return true before it returns. If any of them return false, then it returns false. Now you build these into a larger tree. So you have a sequence of perhaps at the top three of the what I call OR gate type sequences, where any one of them can return as true and things are fine. Whatever actions have been, and of course you have this embedded in your general control loop of, first off, getting the information from the environment, going through the behavior trees, and then at the end of when the top node returns, somehow returns true from the lower activities, then you perform your outputs, general control loop, just like you generally see with robots. So the point is, okay, so you build up this tree, and at some point, whatever action is going to need to be taken returns a true and that somehow filters all the way up to the top node, and that action has set the stage for whatever actual outputs are needed at that point, if any. I have a very general feeling here that I'm totally losing everybody.
Not at all.
It'd be better if I waited another week and came up with some diagrams.
Well, you could certainly do that. It would be helpful. I was intrigued by, I know behavior trees are a kind of a big deal in ROS, and people who seem to use a visualization tool called Groot, where you actually see the tree in a graphic form. And looking through those and kind of getting just an intuitive feel for how it works, and your observation that subsumption then is really just a subset of a way to set up a behavior tree, which is intriguing. I think I see what it is you're driving at here. But yeah, we won't put you on the spot, but if you want to come back in a week with pictures, that would be.
Yeah, basically the OR type gate that I call it is subsumption. It's the addition of the different one, which is an AND gate, where everything has to come back with a true condition, an active condition that makes a difference on there. And that's where you get your some of the additional power in the behavior trees is if you want to walk through a door, you got to have three things at least. Is the door open? If not, then you branch into a tree that opens the door. Once the door is open, if you're walking through it, did you actually walk through it? And then finally, are you on the other side of that? And that all three of those conditions have to be true to say you've entered a room. And that's one of the sequences that can occur in the behavior trees.
So when you do something like that, I mean, do you have to set up? I can imagine that if you have a multiple, like a large set of conditions that have to be met, there might be many dependencies. So is it, how do you deal with the dependencies, interdependencies? I mean, is that just how you build the graph?
Yeah, that's basically it. You start with, what are the conditions that you have to have? If that condition's true, then, you proceed along the sequence to take advantage of the fact that that's true. If it's not true, then you get into a different sequence, which says, here's how you do it, and cause it to become true. So as I say, with walking through a door, first thing you do is the door open. Is the door locked? The door's not locked. You got to unlock it, then you got to open it, then you got to walk through it. Now you're in the other room.
I had a question that I'm going to posit a proposal effectively, that my understanding of a lot of the robot implementations that we've got now are effectively like a control loop that goes through this loop over and over again, 20 or 25 hertz. And the actual behaviors that are being triggered or optional in that loop effectively, with any emergent behaviors, establish what the behavior of that robot is. So let's say we've got a robot that has 6 behaviors and it's running at 20 hertz. And so out of that, you get a particular set of behaviors from the robot. And that's how I think a lot of the robots are running. In mine, I'm using a message bus and all that, but effectively, it's kind of the same idea. So whatever the behaviors that I define and enable will create a set of behaviors in my robot. So what I'm wondering is, rather than try to create it as a tree, we could theoretically keep that same single loop structure, but have a higher level that basically set different profiles. In other words, if let's say there's an available dozen behaviors, but 6 of them are used to get through a door, or 3 of them are used for a moth or anti-moth behavior, we could basically create profiles of different sets of enabled and disabled behaviors from the entire pool of behaviors. And if we could have a higher level control over which profile got set, which group of behaviors were enabled or disabled, we would then get different sets of behaviors from the robot.
you're actually,
We only might need one level above that to create those or to trigger those profiles.
I competed in a NASA competition where I actually had to physically build a robot. Some of my later activities have been all in simulation. And my use at that time in 2013 was subsumption. One of the additions I made to it was the setting what I called goals. And one of the trick was there was an activity, a task in the subsumption that would change what goal was active. For instance, the first thing the robots had to do, and I had 3 of them, was drive off of a starting platform. And so the goal there was pause for a certain amount of time, each of the robots having a different amount of time to deconflict them so they didn't run into one another, and then just drive forward for, a period of time. So one was, 10 feet away from the starting goal, one was starting platform, and so forth. Once they attained that position, then it switched to the goal of search, which was go out and start looking for samples that were scattered around the park area. And each of them actually turned in a different direction at the very end and then started the search from that position. So again, to further deconflict them, they had to search a park area that was 20,000 square meters. So it was a big area and 2 hours to complete the process. So that was my first approach to doing kind of what you just said, of setting, a higher level, some organization that would determine more directly the specific goal that you were trying to achieve. You do the same thing with behavior trees, because that would be what you have up on the very top level of the tree. And in fact, one of the ways you can set up a sequence is, if a behavior has returned true, it's not called again. So, as I said, my first behavior in the sequence would be leave the platform. Once it's left the platform, it's kind of not removed from the tree, but effectively ignored from that point on, because it's true, it's done. And so that's exactly how you handle the highest level of switching between things. And you might get to some other point where you may have completed 3 goals, and say I got a sample back to the starting platform, and I'm on the starting platform, I dropped off the sample, now I want to leave again. Well, then I'll go back and I mark that activity as false and start over again, where it leaves the platform and starts the whole search process again for another sample. And this was a competition, just incidentally, that was called the Sample Return Robot. And the current Mars Perseverance is collecting samples and putting them in little cylinders and leaving them, a trail of them beyond around Mars along its path. The 2024 mission is meant to follow along and find those samples, sample return, collect them, and bring some of them back to Earth. And this competition that NASA had was intended to generate ideas about doing that process.
Let me try, if I can, to understand what you're describing. In the contest that you entered, the subsumption machine you had basically had more than one list of subsumption behaviors. And when you describe goals, what Murray was describing as profiles, you're actually switching which list that you're operating from. Is that correct?
That's correct.
Okay, and
that's really
behavior trees allow you to do that, but without the sleight of hand, if you will. That
Right, it fits more naturally in the whole setup.
Yeah, part because we've had the mailing list discussion about this as well, and it was really interesting because that's kind of where I'm at. I've been struggling in this Python-based robot OS I'm writing, And I've had a couple different goes at this problem with complete ignorance of how it's been done before. And I was basically trying all sorts of different things. And this idea of what I was calling a profile, but I like goal better. Basically, a goal sets, enables and disables a bunch of different behaviors and maybe turns on one behavior that had never been on before. And that's the one that does something that enables this overall goal to be fulfilled. So I like that idea. And I wouldn't have to rewrite my whole OS in order to do that. It would basically be just one level up to kind of set the goals.
Right.
You may remember at one time, Kareem suggested that subsumption is actually a way of sort of formalizing state machines. And by the same token, it sounds like my understanding of behavior trees is it's sort of a way of formalizing if then else statements. Because as you know, when those get into the hundreds, it can get out of hand. And the behavior trees are a way to try to get that back in hand. Does that fit with what you're saying?
Yeah, to a large extent. You know, as I've looked at artificial intelligence, I never worked in the field per se, but was always interested in it. And except for the current work with like neural networks, every approach has been a fancy way of doing if then else statements. You know, it has been, you know, and that's, you know, if you go back to, well, you know, it just has. I think as with subsumption and behavior trees, considering them an extension of them, one of the advantages of them is it's fairly easy to introduce new goals, if you will, new actions in there without disrupting the entire tree. If you've got a section of the tree working, you can add something on another branch of the tree, and that original one still works. Whereas now your new one may do something different. You got to debug it so it doesn't cause conflicts with other things that already work. But it allows the introduction of new things without the disruption that some of the previous attempts at camouflaging if then else were fragile. Because once you added something new, it often broke the things that already worked. These are a little bit more flexible. And I'll point out, as I did in the emails, it's not only using behavior trees, and not only in robotics, but in game playing. Your artificial intelligence in games that you're competing against is often by behavior trees. They've driven a lot of this discussion in working with behavior trees on how to use them, how to work with them, and so on. There's a bunch of articles, and many of them come out of the gaming folks to define the behavior trees and make them, explain them, show how to make them work. So if you're looking for more information, you know, look in the area of gaming also.
A suggestion, this seems to be a large area, and given the level of interest in subsumption, an area that I think, and in ROS, I think an area that would benefit from a sort more comprehensive overview, such as like a monthly talk on here are the basic concepts of this thing. I've tried on a couple of occasions reading the Wikipedia article page and trying the ROS page and other avenues to understand what these behavior trees are. And as Murray alluded, there are some concepts that never seem to get explained. Like, do they get cold at 20 hertz like a subsumption stack does? Or do they sit down in a task until it completes? And then the intermediate layers and the types of layers you can have and the way that they return and how these falses and truths that can come from lower levels ripple up, I think I just want to suggest that would be a rich opportunity for a monthly talk on here are the concepts and how you use them. Not to put you on the spot here, Rude, but
Yeah,
Yeah.
I would Let's certainly don't- welcome that.
let's don't scare him off.
Jeez. Next thing you know, you're going to ask him to run for president next year. I mean, come on, guys.
I'm in
I was
Houston, I'm in
thinking about
Dallas, I'm not in Dallas.
I want to.
Incidentally, my name is, I may be rude, but my name is Rudd.
Run.
Rudd,
Okay.
I'm sorry.
Okay. Sorry. We'll correct
Rudd,
that.
is it short for something like Rudyard?
Yeah, Rudyard Kipling. My grandmother was a big fan of his. Gave it to my father, and I got it from him.
Nice. Man who would be king. I think we have, I missed, someone had raised a hand.
I had one comment I wanted to make. Can you hear me?
Yes.
Yeah, people were talking about gaming theory in the context of subsumption, if-then behavior tree. And when we look at the gaming technology as it is evolving, one of the things which has really come up with is what is called reinforcement learning. Like you do a chess, you move a coin from one place to another. And then when you do that, you get a reward or a punishment. And based on the behavior you do, move a pawn, move a knight, whatever you do at that particular position based on the state, you're not really worried about the state, but you take an action and then you get a reward or a punishment. Based on the reward or the punishment and having done these time and time and time again and figuring out which are the moves which give you the rewards, the reinforcement learning enables the automatic game with artificial intelligence to do those behaviors or those steps where it gets more rewards. Now, once it finds this out, it really is not an if-then. It really is a complex state with a lot of multiplication and mathematics, which enables you to determine. So even though we have behavior tree based on if-then, and say that that is applicable to gaming theory, the point I'm trying to make is gaming theory has got other techniques such as reinforcement learning. And I'm wondering that in the robotics world also, reinforcement learning may have its own place. I don't know whether anybody has studied that, but I just realized it's a different way of approaching to define the next step for a robot today.
That sounds like another good presentation.
I have a little answer for that based on my background in KR, and that is that in order to be able to judge whether a particular result from a behavior is, let's say, a reward or a punishment, you have to be able to establish the context, complete context in which that action occurred. And if you don't have a full context, you don't know whether the bear is standing next to you or whether it's a mountain. Or if you don't have the context, you are very likely to make a wrong judgment about what actually happened. And so part of the thing about building models, world models, is you actually have to be able to contain within the world model all the potential contexts that you want to use to judge behaviors. And if you can't capture context, in other words, you can't get the state, the relevant state of all the objects around you to know which ones are relevant and which ones are not, you can't establish the context, and therefore you don't know what to save as what is the context of that particular action. And if you can't do that, then you can't judge whether the action, it might have been just happened to be raining that day kind of thing. You don't know.
So what you're saying is it is difficult to know whether when an action is taken, if you don't have all the context, whether I should reward it or punish it.
It might be coincidence.
Could be, but if you really look at the way reinforcement learning is done, for example, playing chess, the amount of time required in order to give a reward or punishment goes into millions of simulations. And subsequent to those millions of simulations, it finds a way. So it's a different technique rather than very basic behaviors, but just something to consider.
No, and actually in game theory, like in chess or in Go, the context is always available. You can see all of the moves up to that point. So in those types of simulations, it's almost trivial to figure out what the context is. But when you step outside of that into even the world of shaky, like the robot, with a very controlled environment, but into a more uncontrolled environment, like an outdoor or an uncontrolled indoor environment, You don't know whether the cat is there or whether the door is open or whether the lights are on. And if you can't capture those things and also know which ones of those are actually relevant, you can't capture context. So in simple games like chess and Go, it's not too hard to do. But as soon as you actually have a physical embodied robot, that's very difficult.
Yep, thank you.
I love that you just called it simple games like chess and Go.
Well, that's my point, though, is that they have mathematical solutions. That,
They
you
do
know,
not have mathematical solutions. That's the whole
well,
point. That's what makes
okay,
it.
you
That's what
like
makes them
to poke
difficult.
me, don't you? Like,
Well, I
you
mean,
can actually
that
you
one,
can
that
actually
one
figure
deserves
out
it.
all the particular moves in a chess game, but you can't tell me what a robot's done up
You
to the
can
last moment.
you can figure out the history. You can't project it's still non-trivial to decide whether or not it was a good move or not.
Are you talking
And
about
you
chess?
cannot chess and Go.
Yeah, yeah.
Go is even more complicated in terms of the number of combinations of possible moves in the future. It's not a it's a very deep problem.
I
And
understand that. My
yeah.
point was a bit different, though, and that is that those are entirely abstract constructs. They're not in the real world. They're not in the physical world.
No, I agree. Simulation is a different beast.
Mm-hmm.
I think constrained might be the operant word here, that those are constrained environments.
Mm.
So they're mathematically approachable.
Right. And there has been lots of approaches to them mathematically, you know, whereas a physical robot operating in a house or a laboratory or outdoors is an entirely different situation.
I would agree.
Even for us, I was sure that sock wasn't there yesterday.
Well, cool. What an interesting set of discussions. So now we have another thing to look at aside from subsumption. We can look at behavior trees and see what we can learn about those.
And no one will bring up PID controllers ever again.
Yeah, it'll happen. Just don't go there tonight. Somebody wants to.
David, you mentioned a program that was part of ROS. I think it was a behavior tree display called Groot. Oh,
It's Groot, GROOT.
OOT.
I have a question about pig controllers.
Okay, well, I wanted to show a little something. It's not.
Well, let's move on then. So actually, Doug, so we had David Anderson in queue, and then you, and then now we'll have Ted with PID controllers.
Well, I don't have anything about robotics, so Doug, if you want to go first, I just have a general query for the group, or I can go. Okay, I will go. There's a professor at SMU named Christopher Dolder. He's head of the dance department. He's very talented and brilliant man. And his field is kinesthesiology, which is the physics of movement. And so what they're doing is they're setting up a lab where you have, depth sense cameras and infrared cameras and motion capture and all this sort of thing where they can study dance movement. And this is actually kind of common. There are a lot of these. But what he wants to do, because he's a kinesthesiologist, is he wants to be able to measure the force of the dancers into the floor. And in particular, the example he gave me was that a ballerina up on point on one leg, so 120-pound ballerina up on point on one leg, has the entire weight of her body on the size of about a quarter. And that when she leaps into the air off that one leg, the amount of force into the floor is, he said, it's like a baseball bat hitting a fastball. So what he wants to do is he wants to measure and quantify all these sorts of things. And he wants a floor that can do that for him. So I suggested, well, why don't you just put the sensor on the dancer's feet? And he said, because it might not be their feet. It might be hands or elbows or hips or heads or shoulders or knees. So here's the problem. He wants a 10-foot by 10-foot dance floor that can return where the pressure is on that floor and there might be more than one spot, like if you're on hands and knees, and how much pressure there is on each spot. And I went and looked up, I thought, okay, 10 square feet. So I don't know what resolution he wants, but imagine that it's 1 square inch. So we have 1 square inch pressure sensors, and that'll take 144 of them per square foot, which means 14,400 pressure sensors with a piece of marley on top of them or something like that. Well, that boggles my mind. So at that point, I kind of ran out of ideas, and that's why we don't necessarily have to come up with something this evening, but I know there's a brilliant group of engineers here gathered, and if anybody can think of a way how to think about this problem, that would be greatly appreciated. Doug?
Well, you okay? If you're going to measure the floor, and I got to admit 1 inch, you maybe if you could talk them into like 3 inch by 3 inch, you might you cut everything down a bit. But those sensors that they use in scales, they're very inexpensive. I can't remember what they call them.
Strain gauge.
Strain gauge. Yeah, they are based on strain gauge, but that's not what they call them. Something like a weight cell or
A load cell?
Load cell. Yeah.
load cell. Okay, so those are pretty reasonably priced, and they have essentially per load cell you have to have a real high count 80 analog to digital converter. Okay, so those are, that would be one option if you wanted to direct measurement. The other thing that would be interesting is if you could get underneath the floor and the floor was a membrane type thing, you might be able to say, picture it as a floor that's reinforced at foot level. All right, so you got a foot by foot. So there's a membrane that's a foot by foot in the middle, and you have something underneath that's literally looking at the deflection of the floor. I mean, that you'd have to know what the floor material was, and there's probably some other things you need to know, but that might be another approach. I'm just talking off my head here. So, but if I were trying it, I'd probably try the load cells first, because, like I said, how much does he want to spend on this? That's the other question.
Well, you really have to, in the research establishment, you have to turn that question on its head. You find out how much it costs, and then you write a grant proposal for that money and see if you can get somebody to fund it.
Yeah, I would really, like I say, two possible things. One would be the deflection method. Okay, and if it's that might be limited by the top force they could actually put on it. You know what I'm saying? I mean, you wouldn't want somebody going up on toe and then all of a sudden cracking through the floor. But I'm sure that there's multiple ways to do that if you pose that question to the web. Just they can.
He also mentioned that it has to be able to rebound quickly, because there may be real quick multiple pressure points.
Did you say 10 square feet? 10 feet square.
10 feet by 10 feet.
So 100 square feet times 144.
So 14,400 sensors and wires running to them and microprocessors to read them. So isn't there some kind of fabric or something like that? I noticed Rudd had his hand up. We should let him get his.
Yeah, brother, I had unmuted you, so just unmute and jump in anytime, but just know that your audio has some coupling issues. A couple of our members have that.
I noticed that when I was testing before I joined in. I haven't had that problem with Zoom or other systems, so I'm not sure what's going on. First question, or first thought is how do touchpads work? particularly the ones that, can sense double finger stroking, and same thing with touch screens. What's the mechanism there behind those? Because it sounds like basically what the same type of problem. My second thought was, if you laid down a grid of wires 1 inch apart, so that you had a grid. Yeah, got that, David. And there were strain sensors on each of those wires around the perimeter. It's kind of like multiplexing LEDs on a grid, but in reverse. You could sense the pressure on the XY, the crossover of a point from the outside edges. And then, even if you've got multiple ones, you've got two here, and it's being, let me get my fingers in the right place here. There we go. And it's being touched in two places. You can tell because you're getting tension from this one and the horizontal one. So it eliminates a ton of sensors.
So that would actually just be basically the grid of wires is like a passive sensor. There's not actually sensors on the floor. The sensors are on the edge connected to the wires.
That's correct. And then you have to
I
keep
think
up
the old,
all those tensions.
I think
Yeah.
like the Palm Pilot era PDAs used resistive pressure sensitive display that worked in just that fashion.
Exactly. But that can give you location, Carl, but I don't think it can give you pressure. I might be wrong, but in fact, I actually have one sitting here in the closet where it's just a glass plate, and it's what you would put on top of an iPad tablet to give you touch control. You can get some, it's just a grid, a resistive grid.
I think you can find, like, there are those, like SparkFun has those flexible strain gauges that can measure bend and deformation. So I think with some combination of that, maybe in a matrix and with some known what's the right mechanical term?
You can get where you have the resistance between the wires as a function of the pressure. And so I think something of that ilk might work.
So you could have something like David, like a woven fabric or something like that, where you're actually able to measure the deformation between the wires. Is that it?
Yeah. Yes. That is, it's in effect a pressure sensitive, and I've seen that for screens where it actually will measure how much pressure there is at the one point, so you get not only the X and Y but also the pressure.
That's exactly what he wants.
David,
Now, whether it has the range that you're looking for or not, I don't know, but I'm just saying that as you press down on the two wires, that the amount of pressure changes the resistance, and that since it's an X and Y thing, you know also the location. Now, the issue with that would be as to whether you have multiple points or not, and whether you can determine the difference between the different points.
hey, David, if you actually Google film that changes color with pressure, there's several links on color changing pressure sensitive materials. That might be useful. So films that change color with pressure is the search term.
And I was having luck with the search term woven pressure sensor fabric. So many options.
Yeah. That way you might be able to do it with just some cameras.
Cool.
Well, great. That's all. That's my question, guys. I appreciate all possible input. And if you suddenly sit up in bed in the middle of the night this week and say, aha, all he needs is
This
2 pieces of wire in a diode.
some duct tape. Cool. All right. Well, thank you, David. Next in queue, we had Doug P. And then we had behind him Ted Myers, who wanted to bring up PID loops, either seriously or as a joke. And then whoever else wants to go after Ted is unknown. It's wide open. So, Mr. Doug Parody, what have you got tonight?
Okay, very little, but I want to go ahead and share it here. Okay, let me see here. Then I need to do.
It can't be much less than what I presented. So,
Please, okay. Get in here and do this. Okay, now I'm pinned on here. Okay, can you guys see this? This is a breakout board that's from DF Robot for the Pico, and this is one in my physical hand, so you can see that you can get them. Now, let's see. This is the part right here. They're $4.90 a piece. So they actually cost more than the Pico. But let's look at it. Let's see here. So, okay. So you can see they have all of the digital I/O broken out. They have the 3 analog pins broken out. They have 2 I2Cs where there's 2 things I could think could be used here. You could either hook 4 I2Cs to the single bus, or you could use 2 of these positions to put, well, actually you could use some other positions to do that too, but you could actually use this to provide your pull-up resistors. So if you wanted to control your pull-up resistors from this board, with a little creativity, it would be real easy to do by just plugging them in between the necessary buses. It has, so both the I2Cs are pulled out. It has 2 UARTs pulled out, and then it has some 2 SPI buses. And then it has a general display interface for the tapes that are real common with some of the different displays that they have available now. And this is the power over here. So anyway, I thought that I'm looking at this as a way to use the Pico boards easily, and I wanted to share that with you guys. And that's pretty much all I had to say.
Cool. Thank you. I think, Murray, you had your hand raised. Was there something about Doug's thing for that, or?
I think we've lost Murray.
Murray raised his hand and then he left. I think he was going to leave early. Maybe he has left early, but he comes
I
back.
will tell you, I just got some Pimoroni stuff, so I'll pick up the Murray slack there because I know he's a Pimoroni. I will tell you, I got some Pimoroni stuff that has one of those. You take a Pico board, throw it on there, and you got some of their 4 more packs that you just slap onto the things. Really easy, really convenient to use, and I had a good time with them. Well, me and Doug had some synergy going on there, but we were, so there you go.
It's cool.
I saw Ray was nodding his head there. Ray, have you used those devices?
You're muted.
We're having an audio issue tonight, aren't we?
Oops. Anyway, I've just seen them. Yeah, I thought they were, very unique as far as like a prototyping board. There's other similar things out there like that for, ESP32, for the OpenMV H7. There's all kinds of different boards you can plug onto it. And I actually wanted to show something. Well, it's not identical to that, but it's kind of like an all-in-one package that is, I don't know. Harold, were you done? Should I just go?
I think Ted was in queue next, but.
Oh, oops. Ted?
All right. Well, I will go. Murray kept bringing up PID loops, and I was half kidding, but I do have a question. So, I understand there's a set point, and then there's your like current value, and then that produces an output. Well, my question is, what do I hook up the output of the PID loop to? So, to kind of expand on this, as I'm driving my car, I'm thinking about this, and I'm thinking if I'm not going fast enough, then I want to press down on the accelerator a little bit more, or a little bit less. So I'm not actually changing, like there in my mind, I'm not changing the absolute position of the accelerator, but the relative position, a little bit more, a little bit less. And I've always thought of the output as being where to set the accelerator, like 0 to 100.
No, the output is what goes to the plant. In your case, it's the motor. The input is the encoder checks that come back in. The throttle, or what you're talking about, the accelerator, is your reference.
Okay, but you can't just send a number to the motor.
Ted, I think you skipped a couple of steps there. You talked about an input, and you talked about a set point, and then you went straight to output without going through calculating the error value and
right. And I can look up the
derivatives and all that kind of stuff.
I can look up the formulas and the algorithm for calculating those, but mine's more of a philosophical question. What that output number, what do I hook it up to? It doesn't mean anything.
No, it's still, think of it, the output will be what it needs to do to drive the motor to give you the input that's going to match what your reference is. All right, so you're going to have to limit it. You're going to have to define the upper and lower bounds of your output. But given an input, and given the input's the feedback, if you want to think of it, and the reference is the signal. Okay. So let's take a look at one that you were trying to just. We're going to look at heading error.
Okay.
Okay, heading error. You would normally, if you wanted to go in a straight line, your reference would be 0 because you want your heading error to be 0, right?
Okay.
Okay. Now your heading error is either going to be in radians or in degrees, or degrees per second. Okay. You follow me? So you have a heading error. All right. So you want to go this way, but you're really going this way. This distance in between is your heading error.
So that'd be degrees, not degrees.
That's your, okay, well, that's your input. Okay? Yeah, that's degrees. That's degrees, but you got to remember you're also doing this time slices, but it's easier to think of it as in degrees. All right, then, or you can think of it in angular velocity. Okay, now, so anyway, so it's degrees. So you want to drive those degrees to 0. Well, the PID loop is going to calculate the error. Here you have a big error. So it's going to send a big signal, corrective signal. And if you use David's terminology, it'd be the rotational portion of your motor response. And then it's just going to, I like to actually have the rotation up in my reference. But so it's going to turn a big motor response to bring it back to 0. Okay. Am I being clear here? I see a puzzled look, so I guess I'm not.
I don't.
Well, I mean, but
Well, let's do
that
speed
doesn't,
then.
the
Let's
motor
do
response doesn't tell you where to put your steering wheel.
No, that's your reference. You have to tell it where you want to go.
Yeah, but
So-
that's in Ted's language, though, Doug. I think what you're saying is reference. I think is set point because.
Oh yeah, okay.
So
Yes,
Ted's
you're
saying
right.
you want to have it turned at a certain angle or something. So, see, Kumar, the set point is where you want to turn it to, and then there's some feedback that says where it actually is turning at the moment.
That's the input.
Okay, whatever Ted wants to call it current value. So, and then you mix those together and develop the error and put it through the math,
motor.
and out comes the output. But I think philosophically, to me, Ted, you were asking about the output. So to me, that depends then on actually what are you connecting the output to? Because you might, like in the heading or steering, you might connect the output to some whatever that pinion steering is in a car. So that might be one kind of output, or you might connect it to differential signal to differential wheels in a robot. That'd be a different kind of output. But fundamentally, you're still measuring a set point compared to a current value. So I think philosophically,
And that's the measure.
Steering wheel, and so your output is going to drive a motor that turns the steering wheel, but the motor is controlled by a voltage. So your output is a voltage that goes to the motor.
It'll be a number. It'll
In
be a
that
number.
case-
If it's normal, it'll be probably somewhere between minus 255 and 255.
But,
Yeah,
but see, that's not going to work.
Can may I try?
Yeah, go ahead.
Okay, let's back up a minute. When we talk about pig controllers, there's actually used in this group, there's two different flavors. One flavor is a pig controller that controls position. The other flavor is a pig controller that controls velocity. So when you're talking about steering, that's a position control. When you're talking about speed, that's a velocity control. So let's narrow it down to just velocity for this.
Okay, that makes it easier. Yeah, I goofed that up. I should have probably just went with velocity. So
Okay.
yeah,
So you have
a set point.
You have a robot.
5. Yeah.
No, I get to do it.
Go ahead.
So you have a set point. You have a robot, and let's say, to make things simple, that its speed is controlled by a value between 0 and 100, or 0 and 1, or whatever you want, where 0 is stopped and 100 is full speed. Okay, now you want the robot to go 50, but it's currently going 0. So your set point is 50, and your current reading, your current sensing is 0. And so
That's your input.
that's the
Your input is 0.
So the error in this case is the difference between what you want and what you have. So what you have is 0 and what you want is 50. So the difference between them is 50. So since this is a PID controller, the proportional error is scaled by something. So let's say it's scaled by 0.1. Or
Make it 1 or 2. Make it 2.
So it's going to be a different value than the actual error. And you're going to then, in the PID controller, you're then going to accumulate that. So the question becomes, when we've actually reached 50, that value is going to, each time around the loop, that value is going to build up until we've actually got a velocity of 50. So we want a velocity of 50, and we've got a velocity of 50. So the error is 0. But you don't want to send a 0 to your motor. You want the motor, you're trying to tell the motor, whatever speed you're going now, stay at that speed. So the 0 represents basically the offset that you're going to add to that every time around the loop. Once you reach the proper speed, the error goes to 0. So in this case, you can think of a simple controller that's just a PD controller. So it's got a proportional and a derivative term. And the output of that is accumulated. The output of that is integrated. It's that integrated output that drives the motor.
You just said integrated, so now you got a confusion because you're really saying a PI controller.
Well, except in this case, the P and the D are basically driving an output, which is an I. So it's really a PD controller. 6 of one, half a dozen the other.
Okay. Yeah.
So
in this-
what you're saying is you're really controlling the change of the, like, let's say the motor, it's electric motor, so it's running on a voltage. So you're increasing the voltage until you get to the right speed, and then you stop increasing.
That's right. And because it's a PID controller, the error gets smaller and smaller as you get closer and closer to the set point.
Right.
So
Okay.
that's what differentiates it from a linear controller, where the amount of error remains the same each time around the loop.
Okay. So the output is not the voltage you're sending to the motor; it's the change in voltage.
No, it's the output you're sending to the motor.
But so what I'm
imagine
saying, let's just go back to proportional. If
Okay.
your
Okay,
error is zero,
that's a good one.
then you don't change the output of the motor. If the error is positive, then you decrease the output of the motor.
No,
And if it's negative, you increase it.
Yeah. Let's run it through. Your stop. You want to go 50. All right. You've got a KP of 2. All right. So the first time through the loop, your error is 100. 50 times 2.
No, that's not the error. That's
Yeah, that's the error, because your
the error
difference,
is
you're stopped and you want to go 50. So the
The
error
error is
is
50.
50. But it goes through, it's multiplied by your KP of 2. So 100 gets sent to your motor.
okay.
Okay, now the motor's moving something. Let's say it's going 25. All right, so now you come back up and your output 25. You want to go 50. So the difference is the error is 25. Okay, I could have said 30 and the error would be 20. Okay, and that times 2 will be 40, and that'll go to the motor the next time.
But no, that doesn't go to the motor. Well, you add 40 to your 100, and now you have 140 going to the motor. Is that correct, David?
It's the phrase "going to the motor" is what's throwing us off here. So picture the PID controller running out in outer space, disconnected from anything. I'm going to use my hand. So my hand here is the output of the controller, which in the case I described is actually the I term. So if the error is 0, it just stays here. But if the error is positive, it pushes it. Positive error means we're going too slow. So the motor needs to be speeded up. So we're going to push the accelerator to a higher level. If we shoot past the level we want, then we need to slow back down. So we'll get a negative error and we pull the accelerator back down. But if we're going exactly the speed we want, then the difference between what the motor says and what we ask is 0. So whatever position we have found is the position we want to remain at. And we will, because each time around the loop, we're only adding 0 to that value and it won't change. Now, how that value actually scales to a voltage value is independent.
It doesn't matter.
So
You're
if
right.
your voltage goes, or you have a controller like the RoboClaw wants -1 to +1 floating point. These little H bridges that I use want 0 to 255, where 0 is full negative and 128 is stopped and 255 is full forward. So that has to be scaled from the output of your PID controller. And the PID controller, often if you look up the examples, the PID controllers are all scaled to 1 anyway, just because it makes all the rest of the math easier. But whatever that value is, when you reach the velocity you want, you continue to send that same value to the motors. And then the set point can remain the same, but the measured value can change. For example, you hit a steep slope, so you begin to go uphill. That causes the robot to slow down. So even though our set point hasn't changed, the robot's velocity has, and we need to give it more voltage in order to maintain the speed that we want. Ted, does any of this help?
Yes, I have figured it out now, and I will restate it, and you will probably say that I don't understand it at all, but to me it makes sense. So the output, if the output is 0, whatever the output of the pig controller is 0, whatever I happen to be sending to the motor at that time, I send that same number. So if that number is 128, I send a 128. If the output is positive, like let's say it's
Let me stick my nose in here. I think
Okay.
you want to use the word error rather than output. If the error is 0, you continue to send the same value to the motor. If the error is positive, you increase the value. If the error is negative, you could increase the value. But if the error is 0, you stay where you are. You're at the right velocity.
All right. Well, so I think you're mixing two terms. The error is the difference between the set point and the current measured value, correct?
Yes, and
Yes.
if that error is 0, there is no difference between the set point and the current measured value, meaning the value you are currently sending to the motors is correct.
But the output of the pig controller is not equal to the error.
Correct.
Right.
So anyways, if I get an output of the pig controller and that output happens to be on a scale of 0 to 1 and that output is like 0.5, that means I'm going too slow. And so I'm going to increase my signal to the motor controller so that the motor controller goes faster. If the output is negative, then I need to decrease my signal to the motor controller.
I think you're confusing the word output with input.
With error.
Yeah.
Well, the input to the output of the pig controller it's translated into the input to my motor controller. So the output goes to the input.
But if an error is 0 and the PID loop is working right, then whatever the current value is going into your motor controller, it's the right value and it'll hold it.
Right.
But if the error is up or down,
if my error is 0, I should not turn off my motor controller.
you hold wherever it is.
Yeah.
Yeah, continue sending. That's why I was using for the gain constant a number less than 1. Doug chose a number greater than 1. But
I thought it'd be easier to do the math.
But basically, if you think about it, just a P controller, ignore all the rest of that. Then when that constant is small, that means the number that you're accumulating is small. And so it takes a long time to get to the set point. If that gain number is large, that means the values that you're adding, that you're accumulating, are large. And so you get more quickly to the set point. However, excuse me, choking on my own words. However, when the value is large, the problem with a proportional controller is that you'll overshoot the set point and you'll continue to oscillate around it. That's the problem with a pure P controller. So you add the derivative term, and the derivative term allows you to basically have a large value. Let me rephrase that. The derivative term allows the whole PID controller to move rapidly toward the set point, but still accurately find the set point when it gets there.
Yeah, I have a little different look at it. David likes PD controllers, and I like PI controllers. If you want to be absolutely on the value, if you want 0 error, the only way you can achieve that is with an integration term. If you do it with one of the problems with proportional is that as it approaches the value that you want, your reference value, what will happen is the proportional actually runs out of steam, and it'll steady state at some value below your desired portion. And you can crank it up and it'll get closer, but then it does the ringing that David told you about. So, but if you keep it where it's completely critically, where there's never going to be any ringing, you'll see that it comes out and there'll be a gap between where you want to be and where it is. The only way you can close that gap is with an integration term.
I don't disagree with that. I would go ahead.
I was just saying you can also address it with a feed forward, but there's cases to be made for, a PIDF or whatever, that it all depends on things like the amount of resistance you've got and massive, it's the actual dynamics that you got to adjust. And that's the whole tuning process. But that tuning process, regardless of which stages or components you choose to activate, once you get a tuned output, that is directly what you're sending to your motor controller, right? So that's it. It is the output of the PID controller that is always driving your motor, that you're actually sending that number, if it's properly scaled. But the tuning process is what makes it scaled correctly for your actual hardware motor controller. Does that make sense?
So let me throw this out there. I found a PID library in Arduino, and I hooked it up to my wheel sensor and to the motor. And, I put in the K, I think I just did derivative with the derivative value.
No, derivative. You have to, you can do just proportional.
What happened was when the motor was stopped, it ramped the motor up to maximum, and then it shot way past the set point, and then it set to negative and shot way down, and it bounced. So then I turned down the K value way down, and it gradually worked its way up, and then it, as soon as it got to the set point, it would set the motor, the output would go to 0 because the error was 0, and it would turn off the motor. And then it would repeat. So it was bouncing up and down, and it would do this jerk, 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 because I was setting the output directly to the motor, and apparently you can't do that. You have to.
No, your problem was you had the gain too high and no derivative.
Well, no, I mean, I set the gain high, I set the gain low. When I set the gain low, it just took longer to cycle back and forth.
Okay, are you using the one, this, what do they call it? PID
but what I'm
version
saying
1?
is you can't take the output and send the output directly to the motor. You have to add the output. The output tells you how much to change what's going to the motor. It doesn't tell you what to send to the motor.
Well, Ted, that's correct if you then take the output and integrate it.
Right. So you have to integrate the output. And
yes.
Yeah, that's what
Since you're integrating the output, that becomes the I of the PID.
That's for speed controller specifically.
Yeah. For speed controller, yes.
Yeah.
If you're just doing position control, you don't need that step.
No.
Okay. Yeah. So what I was doing was a speed controller, and you have to.
And I swear I heard you say that you were starting out with derivative, and that's not right. You got to start out with proportional.
Yeah.
Oh, yeah, I might have misspoken. I was doing proportional, not derivative.
Yeah. Now, one thing on that, you have to, couple of other things that you have to set on that on that particular library that I think you're using, which is you want to make sure that you have a loop, a PID loop time that goes into it, and that what happens is that has no interrupts in it, so it cycles through your loop, and whenever that loop time is achieved, then the PID fires off one time. Okay. So you want to make sure that you're setting those things correctly, because you could get in, if it's not set right, it'd be a problem. But if you want, I can, if you want to talk about that particular library, because I've worked with it. In fact, I use it right now.
Yeah. No, I think I understand how that library works. My misunderstanding was what to do with the output. And I was trying to send it directly to the motor without integrating it.
Well, see if I can.
So yeah, I think I got my questions answered. Thank you, guys.
Well, I'm sure we confused you more. But
That's good. Always good to
You don't
revisit
want
that.
to integrate the output. The output is directly to the motor. You need to set up the terms of the PID loop properly so that you have the right gain and crank up the derivative term to keep it from oscillating.
Well, so Dave, let me ask you this. If I've got the motor set so it's running at the speed that I'm getting the velocity I want, and then the error is 0, the output is then 0. And so I don't want to turn the motor off.
The output is not 0. The error is 0, but you're accumulating the output. You're integrating the output.
Right.
So
right.
so the 0 from the error is not changing the accumulated output, but it is not 0. The error is not, I'm sorry, the output is not 0. The error is 0.
So I agree with that, but you have to integrate it because otherwise the output would be 0.
And it is true, as Doug was observing, most PID controllers in the world are PI controllers. The D element is added by those of us who are picky about how we want the response curve to look. But most controllers in the world are PI controllers.
Okay. Ted, I'm going to show something here that might help. All right. So here is kind of some code from one of mine. So here you can see I have two PIDs, one for the left motor and one for the right motor. Here you can see I'm setting the reference. Okay. Now I think this is where I do the rotation, but I believe that David and those guys do it later on, and I'll show you. So here's the input. It's the encoder edges to velocity. Otherwise, I take the encoder edges and turn it into a velocity. All right. Now, if the timing is correct, and it's ready to run, then it'll trigger. And I said some stuff. Don't worry about that. But this is where the actual PID is computed. Okay. And then I just set the motors to the output of the left and right motor. And that's it. That's the whole thing.
So you're not integrating it?
No, well, then, no, not mine. On mine, I'm using, well, okay, here's where we go. Let's go here. Okay, you can see I have set point. I actually have 3 because I do one for the heading error. But so here you can see I have KP set and I have KI set. But I don't have, in my case, I didn't need it for this particular robot. I don't have any KD. I have used KD. If you're doing line followers, you might have a KP KD controller and not have it KI because you don't really care if it's going exactly the speed that you're wanting to go. So I don't know if that helps any.
Ted, this library has the integration inside of the PID controller itself. So you don't need to integrate the output of the PID controller because when Doug set the KI term, the PID controller itself does the integration function.
Yeah.
And I put the link, I think it's the same library, Doug, if that's the same one used in a club robot, that's the same library I'm using.
Yeah.
So I
That's
put links to a pretty recent version of that library in the chat, along with, I called it ultra detailed explanation of why the library is the way it is. And I found that as a really helpful way to walk through, because he kind of builds it up from first principles in the way that everyone's been talking about. Start with P and then you add these extra embellishments.
Well,
And,
I will look at that. The library I was using, if you just use the proportional gains, it would, if the error is 0, then the output is 0.
that
Well,
doesn't sound.
That's correct.
That's correct. That's proportional by definition, because it's
Yeah, but that's not integrating the output then.
no.
That's exactly right.
So it was doing what it should have
Right.
been doing. But if
So
you gave it an I gain,
so I would have to integrate the output.
or if the PID library that you had would allow you to set the KI term, then you would give the KI term a number bigger than 0. And then that library would do the integration for you.
Okay, so I think we're talking about two different integrations here. There's the integration in the I term, and there's the integration of the output, which are two different things. And I think you have to
One does not integrate the output.
There's only one. It's either in the loop or it's on the output. But you can't integrate the integration, or you don't want to.
Well, in practice, if you remember that the robot has mass and it accumulates momentum, then there is another integrator. But
yeah, and it generally works in our favor by smoothing out all the bumps.
but there's no need. You don't want to. If you have a PID library that lets you set the KI, you don't. I think you don't want to add an integrator outside of it.
So David, you're saying you always use an integration term.
Yeah, is that the question? Yes. And as what happened to my camera?
It's disabled.
It's gone.
I didn't do it. There you go.
Allow. I'm allowed. I'm so pleased when a machine allows me to do something. I'm sorry, Ted, I lost my chain of thought.
No,
the ones that I have used successfully on my robots, inside the loop run a proportional and a derivative term. And the output of that loop drives an integrator, an accumulator. And that accumulator, scaled appropriately, drives the motors directly. So when the output of the PD is a 0, then whatever is in the accumulator currently is the right value. So you still add the output of the loop to it each time around, but the output is now 0. So you're not changing that value.
Okay, yes. So I am with you on that. But you have to accumulate the output of the PID controller to send to the motor. Because if you don't accumulate the output, as soon as you get to the right velocity, the output would shut off if you directly tied it.
Exactly right. You can see how with a position controller, that's actually what you want, right?
Yes.
Once you reach a position in your CNC machine, you have 0 error. You don't want to move anymore.
Yeah, you don't want to move.
But you can think of the location of the head of that CNC machine is like our accelerator.
Yep. Okay. So I am with you on that.
So, Ted, definitely try out Brett Beauregard's library. It is truly a good one.
It's well done.
Okay.
It's well done.
And there's a few of us that can help you with it.
Mm-hmm.
Okay, cool.
All right. Well, good discussion, lively at least. And
yeah.
Good. Cool. All right. I think Ray, you had something to bring up at this point now.
Yeah, I got a Wii terminal, or Wii-O, I guess is maybe how you pronounce it. Let's see if you can see it. I can crank this down there. And of course it's too bright. Let's see. No, still too bright to see. Anyway, it's based on the SAMD 51, and it has just a bunch of stuff integrated with it. It's got Wi-Fi and Bluetooth. The Wi-Fi is at 2.4 and 5 gig. It's got a little 5-way button on the front. It's got a 3-axis accelerometer, a light sensor, an infrared emitter, micro SD card slot, and a microphone and a buzzer, and 2 Grove connectors. And it has a 40-pin connector. You can actually stick this on the Raspberry Pi 40-pin connector. And I was thinking of using it. I wish you could see it. You can't really see the lines, though. It's just too bright. As kind of like a, the user interface, basically, because you can put on the screen to select through with a 5-way button. Oh yeah, it also has 3 buttons on top. And it just seemed kind of pretty compact and loaded with stuff. It's got this, the SAMD 51 is a pretty fast part. And it was
What's the make and model number?
Ray, can you put a link in the chat?
Yeah, sure.
I think I can do better. I have something to show you that ties directly into that, actually.
Ooh, all right.
So, wrong button.
Yeah, it's WIO terminal, and it's made by Seed Studios, SEEED Studios.
I think this is the render I want.
Are you gonna pull something up? Okay.
Yeah.
There you go.
So, speaking of that, that's how it looks. And this was used with this project, which I was like, as I was looking at it. So, yes.
Yeah.
And yeah, it was that was interesting. And then also the fact that notice there's no 3D print involved.
Yes.
With their base, they use tubes.
Yep.
So yeah, this whole article was interesting. So
they're using plumbing fittings, huh?
Yeah, that's why I said that was sort of interesting for a couple reasons.
Yeah. Anyway, it's the WIO terminal.
That.
Yeah, by Seed Studios. Or Seed Studios.
I put a link for it in the chat.
I actually have another window with that red, but this ties into that thing. So, but yeah, right there.
See. Terminal. Yep. Anyway, so I thought it was kind of neat. $36. It includes a lot of stuff.
Yeah, so you can see, this whole list here: buzzer, phone.
Yeah, and the SAMD 51 is a pretty high performance core. I think you can push it up to 200 megahertz. I think.
So you use that, and then the shield. And then here's the circuit board. Somewhere in here.
So you can drive 4 motors with it, huh? With that.
Yeah.
Yeah.
Yeah. What is a Grove connector?
It's
Grove.
I don't know who defined Grove. It's they can be, usually it's BCC ground and either like a digital output or an analog input, or it can be I2C. So you can have, it's a 4-pin connector, and you can have, it can supply power and ground and SDA and S clock for I2C connections. And Seed Studio produces a lot of things that you can connect that way. It's kind of like the quick connector from SparkFun or Adafruit they're using on their stuff now. It's, no soldering required. You just snap these 2 little connectors together and you've got 4 wires that goes, provides power and a communication interface of some sort. You can even have it so it's serial, RX and TX, with power and ground. So that's the 4 wires. But yeah, it's actually this little program that's running on the display that you can't see because it's so bright, is actually spitting out or graphing the accelerometer readings. That was one of the programs that you could, example programs, and you can put up text in boxes and, pretty
As
much
an
all the
example,
graphics.
there on the case with their, yeah, you see here the speed, the weather. So that's the rental.
Yep. Yeah. So I thought it was kind of neat.
And there's, yeah, the terminal. So yeah, it's was very interesting playing. So Ray, you
Yep.
may want to look at this more closely because they have lots of info on it here.
Yeah, and the fact that you can set it on a Raspberry Pi or
Yeah.
just use that 40-pin connector for whatever connections you want. Seemed pretty useful. So
let's see if I can actually go to the other window now.
And the other thing I did, I was a little afraid that, with shortages and stuff, I couldn't get stuff, or if I waited a little too long, stuff wouldn't come in. So after John, yeah, so that's somebody else's.
But yeah, $36
graphics design. Yeah. So you
yeah.
can do like, vertical bars if you want. You can do like analog meter readings where you have a needle that actually scales up and down. And I'm sure probably as more people get to use it, there'll be more of that kind of thing. So it's kind of like the Nexion displays. You've got, you can create pretty much what you want wherever you want on that display, and interface to things like you would with Nexion with a widget or something, where you just provide one value to the code and it displays it, moves a bar or moves a needle, that kind of thing.
Seems you can run a GPS navigator on it and stuff.
Yep. Yeah, you can. They have a GPS device that hooks up to the Grove connectors, and you can spit out coordinates and that kind of stuff.
So Ray, new toy. What are you going to do with it?
What's that?
New toy. What are you going to do with it?
Well, I'm thinking of using it because it has Wi-Fi as kind of a user, remote terminal user interface for the lawnmowers, where I can set, like that pattern that I showed you guys that the thing was able to perform over and over again. It kind of zigzagged back and forth, like to put in the number of repeats for the pattern or the distance or both, and just to get some telemetry back, battery readings, that kind of stuff. So I thought it was kind of neat. Very small package, still reasonably priced. I don't know if they're going to increase the price later on. They probably will. But and one of the other things that I got were a bunch of mechanical parts. I found these. These are solid plastic wheels with a pretty good tread pattern on them. And I think these were like $4 each. They've got 2 different size bushings. You can pull the bushing out if you want. If I can get this one out. Yeah. Okay, this wasn't the one that I pulled them out at, but you can pull them out. I guess you'll just have to take my word for it. Anyway, so I've got, bushings, bearing, keyed shaft, sprockets that go on it. And when I was working, we do, my wife and I do grocery pickup. I got a, let's see here. this is it's a pretty thick plastic bin. This is about probably a little over a half an inch thick there. And I'm guessing it was used in the store somewhere at Albertsons, but I decided to grab it, and I'm going to use this super thick plastic base because it's very rigid, and it was free to make a a robot that can do Robo Magellan, and these are going to be the tires in it. There's no slippage because it's a one-piece wheel, and it's got the pretty aggressive tread on it. Got all the sprockets and stuff like that. This is 35 chain sprockets that fit on a half-inch keyed shaft. So I have most of the parts. I'm waiting for pillow blocks, half-inch shaft pillow blocks to support it. And I also got some 16-inch tires on rims for the riding mower. I was going to try something with to basically steer with 2 brakes on the differential. So if you brake, stop one side from rotating, the other side will still rotate, and you can use that to rotate or turn the platform basically. And but the tires that I had on were really wide. They were like 8-inch wide tires. There wasn't enough shaft left to stick a brake disc on it. So now I have 4-inch wide tires of the same height, and it should give me plenty of clearance for to be able to stick the brake on the axle. So, and got chains and sprockets for that coming as well. But anyway, yeah, Seat Studio I think does have some reasonably priced stuff. They have another device that I think it's called the Re-Terminal. A little bit more expensive, I think very new, not as well supported. But this one seemed to have quite a bit of support. So and just all the features, especially the 40-pin Raspberry Pi connector on the back. I thought, that's something I want to play with. So anyway, that's all I got.
Pretty cool, making progress.
Yep. Carl, I want to leap in here and point out that you are the only one who got a gold star this evening.
Oh. I mean, the lengths you have to go to get a gold star these days, guys. Come on, it's not that difficult. Somebody can do better than this. Somebody needs to do better than this. Chris has enough gold stars for several months worth, but okay, thank you.
Yeah, I gotta take a break.
Chris has been accumulating them. Rudd, for this inside joke, basically, if anybody can turn on their robot and show it moving at all, we give them a red gold star.
And you're muted, Rudd. I muted you for the audio. Oh, Rudd, we've been waiting. You need to unmute and tell us about that because
set it down and turn it on, and you get a gold star.
Somebody had been promising to show the group one of those for the last year and a half, and they haven't done it yet. So you could steal their spot and do it.
Wow.
That's the RUR, isn't it? I think. Yeah, and you're still muted, Rudd. I muted you. You'd have to unmute.
There we go. So Sphero RVR, and I've been disappointed because it is such a powerful little unit. But Sphero educationally targets education. But they tend to target more, what do you say, junior high level. Whereas this thing is definitely a high school level type of robot and probably could serve as undergrad college robot work. It's a tracked robot. It's got a serial communications port for controlling it from another processor. You can put a processor on board, mounted on there, which I've done. Right now, it's just hooked up to my PC because I've been reverse engineering their protocol in C++. They provided Python code, and I don't do Python. It's got an IMU, so it's got an accelerometer, gyroscope. It's got a magnetometer, but as we all know, magnetometers within a robot are problematic. The motors and everything else just confuse it. It's got a bunch of LEDs on it. It's got some light sensors, but they're on the bottom, so it's useful if you're driving over a colored pad block. You can tell what color you're on. Not terribly useful. Again, that's part of their younger educational thing that somebody can put a red block down there, a red pad down there. The robot drives over it, and when it sees red, it turns right. That type of thing. So I think they haven't pushed it to the market that would really take off. And now they're suffering part shortages. Last I looked, you couldn't get one until June 2022. So I don't even know if they're going to be available. Even then, they may abandon the whole thing. I don't know. Haven't seen much discussion about them elsewhere. So I've been so busy reverse engineering the protocol. The original version of it wasn't too effective as far as driving. Like its slow speed was, they readily admitted after a while, was not controlled properly. They reversed a new version of this firmware last August, a year ago August, and I missed it. I didn't realize it had been released. But I started working on all the new version of the firmware, a few months ago, and I've got most of it figured out now. So hopefully at some point I'll actually be able to do something with it.
Hey, I had an unrelated question. The OAK-D light, has anybody responded to how they want the thing shipped yet?
They haven't sent it out yet.
No, I've got one ordered too, and I haven't. They just had an email that said they were gonna real soon now.
Put out a survey, I guess.
About shipping.
Yeah.
I think we had a discussion around what was the best default option on the camera, because you have two options. And Carl, can you remember what we chose? Was it the fixed or the autofocus?
I think it was the fixed.
Yeah. For a moving robot, I think it was the fixed that made sense.
Yep.
Yeah. But no, I've not received anything either. So I think they're just not ready yet.
Okay. Yeah, the last one, it said they were going to send out a survey. I guess they're going to respond with how you want it shipped.
First shipments would be in December.
Say that again.
First shipments will be in December.
Yeah, right.
It's so interesting to me how much variance there is between different Kickstarter campaigns. I've done a bunch of them now. I mean, bought a bunch of them now, and some of them, boy, they say it's going to deliver on this date. It comes out at that date. Some of them say, oh, well, we went back into this. Oh, well, we went back into this. Oh, wait, 2 years later. Harold and I are still waiting for the latest Bluetooth DMM oscilloscope thing. So,
Luxonics
yeah,
is
but we got a date. We got a date coming close, man. It's close.
Yeah,
any day now.
It could be.
Well, I've got this. I'm on the Kickstarter for the little Scout robot, and the only thing I can say about that project is at least they really do a good job of communicating the problems they're having with their suppliers and with their manufacturing, and they show, they're giving all the information necessary to know why it's delayed, rather than just leaving us in the dark. So that's good.
That's a good sign. The ones that get me are the ones where they look good for a while and they beat the thing and they give an update or two, and then it's radio silence, and then there's a year and a half of griping and you never see anything.
Well, Luxonics is hedging their bets. If you go to their Discord, they have a whole channel about the shipping, about shipping delays, and they did send out an email to all of the subscribers that was saying, we think we're still online for December, but stay tuned. So we'll see.
And to be fair, everyone's in the same boat. You know, the whole container crisis and all that is like, it's way out of the control of a lot of vendors.
Mm-hmm.
Well, they had a previous version of that. Kareem, is that the one you have?
Sorry, the regular Oak D.
Yeah.
Yeah, I got one of those, but that's not the one I've been messing with the most. I've been using the Intel RealSense.
Oh.
D435. So I also have I did get the Luxonics, the Oak D, a couple weeks ago, but I haven't had a chance to play with it yet.
Yeah, didn't someone say that Intel wasn't going to produce those anymore?
Intel isn't producing a lot of the stuff in the like the extended products that they were investigating in the RealSense line, but they are still doing the stereo cameras.
Oh, they are. Okay.
Yeah, they're not doing the tracking camera going forward.
Oh, it was like a 265, I think.
Yeah.
Yeah.
It seems to me that Intel has a long history of doing interesting, often even consumer grade kinds of little experimental products, and they run for a while and then they close them down.
Yeah, they do that. So does Microsoft. Intel also used to be the primary driver of OpenCV.
Yeah, don't mention the words Edison to me or Zoom. I'm just saying.
I'm with you, Harold.
Yeah.
Kareem, that was an Intel D134.
Sorry, which?
The RealSense?
The RealSense? No, it's the D435.
435.
Yeah. And there's a D435i that has an IMU in it. That's what the I is for. And then they also have a D455, which I ordered a few months ago and they said would ship in October, and I haven't heard anything about it, and it's no longer October. It's the most expensive of the stereo cameras, and it also basically has a better, deeper field of view in terms of the reliability of the depth solutions, and basically twice as deep, and also has an IMU on board.
Does twice as deep mean 4 meters instead of 2?
Yes, that's what it means. I mean, in practice, my 435 goes deeper than 2 meters. It goes quite a bit deeper than 2 meters, but what you see is a lot of depth noise once you get past the 2 meters. So the 2 meters is about the range where it's pretty precise, like within a centimeter of depth resolution. And I haven't characterized I really haven't played with the Luxonics yet, so I can't comment on that one.
Hold some comments until later.
Yeah,
we do the group team unboxing, and then we'll have a free for all.
You bet.
All right.
I'm still not sure what the differences are between the Oak D and the Oak D Lite in terms of like internal hardware. It does look like the Oak D Lite is smaller, and so the two stereo cameras are going to be closer together, and it should not have the same capability. Like the 430, the Intel 435 is probably somewhere in between the Oak D Lite and the Oak D in terms of the width of the separation of the cameras, and the 435 looks about as big as the Oak D or or maybe bigger, more, maybe wider. So, but that, you know, the amount of separation you have plays a huge factor in how deep it's going to get good resolution.
Yeah, I thought the OD light, the camera resolution wasn't as high as the OD.
Yeah,
that's one of the things that makes it light, you know.
Yeah, I'm sure that it's that, and it's definitely more compact looking from the photos.
And of course, there is a discussion of that comparison for anybody interested. So here's a quick Google search. All right. Well, I typed that. Seems like we're all maybe entering hibernation mode here. Dark, dreary, rainy weather, no sunlight, at least in Dallas. Of course, Murray is wide open. He just wants to go down and do some plumbing in his basement. But what else do we have tonight? Anybody have some other topics to raise? Oh, Pat.
Go ahead. Go ahead, Pat.
I've got a.
I was gonna ask a question of David, but maybe I should just do it on the list.
Mine's fairly short. It's not. I don't think it's going to be too long.
Okay, and then I see Rudd raising his hand after Pat. So let's go ahead, Pat. What you got?
Just a quick. Can everybody see that zoomed in?
Yippers.
JST connector.
Female.
Red and the black. I need to reverse those two. Has anyone had any luck popping those little metal pins back out and being able to swap wires? I did the only solution I could do after work, trying it for like a couple hours, is I just cut the wires and resoldered them on the other side.
I actually do that with DuPont connectors and JSTs using one of these really, really sharp pairs of, I guess these are needle nose tweezers. And you just basically jam the point of the thing into the lock, and then you can pull the wire out.
Yeah.
Okay. I tried with a pin to jam it in and see if I could get it to unlock and pull it out.
Well,
no luck.
These are stainless and pretty sharp. You could actually put one into your finger if you're not careful. And but they're hard enough and strong enough that they'll actually push the little lock out of the way. So I do this all the time when I'm reconfiguring my wiring harnesses.
Okay.
I don't know if it with X-Acto knives.
I just cut it and soldered it.
Who said X-Acto knives?
I did.
Yeah, same thing. You can depress those with an X-Acto knife point.
With an X-Acto knife, okay. I've like I say, I tried with a pin and I just couldn't get it to go, and I didn't want to break it, so I ended up okay. Well, I'll just cut it and solder it.
And an X-Acto knife and this thing are just equally able to puncture the end of your finger. So, yay.
I use a dental pick.
Ah.
I've still got one finger I can't feel on the tip from using a Bix punch down tool, and I drove the cutter tip through my finger.
I've used jeweler screwdrivers to get in there. The very, very finest jeweler screwdriver will get in and and lift that pin or move it around, push it in actually.
That's actually probably better because they won't snap like the X-Acto blades do.
Yeah, well, I didn't want to break it, or you know what I mean. I've got a couple, but I don't want to go through everything I had. And like I say, I just ended up cutting it. But I never thought of like the tweezers or something like that.
You know, when I usually try to do what you guys have done with pop out those JSTs, I usually can get them out. But then when I put them back in, there's been enough stress on those little connectors that they will pretty much almost guaranteed break off right at the connector, the wiring will. And so I have to just make my own again anyway. I usually just cut them off these days. And then, I got lots of those little ends around to do. And I got a very nice pair of crimpers, and that made all the difference when making those things. I don't have a link because I'm driving down the road or whatever, but I can send them out to the DPRG list. And the crimpers made made it way better and way easier and way more consistent with getting nice, good crimps on the JS.
So
Harold, you look like you're in a cheap slasher movie.
Just a couple days late, right?
oh,
Is this right before the aliens descend on this vehicle?
I think they just got him.
In a slasher movie. He is.
Yeah, they just
Gonna see a glow in the dark head right behind him in a minute.
Yeah. Oh, he's already glowing. Wait a minute. We can fix that.
Rudd, I think it looked like you were going to pull up your RVR, were you? Yep, we see it. And you're muted still. If you could unmute. Or we could learn sign language. One of the two. Something like that.
Still muted.
Oh my goodness. Why did I click the button? There's got to be an unclick button.
We cannot hear you, Rudd.
They got another microphone.
There it is.
Okay.
We can hear it. Oh, lights. Threads. Action.
Gold star.
Yeah. Very nice. So is that your target for the next week, Rudd, to work on the API and have some code that moves it around? Oh, muted again.
What was that?
Is that your target for the next week, to work on the API, reverse engineer, and then have some code to move it around?
I've just got a little bit more to do. Actually, I could set something up to drive it around now if I wanted, but there's a couple more driving routines and response routines that I need to finish to wrap it all up. But between that and the behavior tree stuff next week, we'll have to see which one gets done first.
It's all good. It's all good. It's great to have a fresh perspective. So welcome. Hope you come back.
Absolutely. Absolutely.
Yeah. All right. Well, swinging around, any other thoughts from the gallery?
I have a question. I've seen this, and I suspect that it's just hype. But since I've never, don't own one and don't plan, I'm kind of curious if anybody else has already bought one of these or seen this or heard some feedback on it. I'm going to do a little quick presentation just to show the web screen. Has anybody seen this? It's quote a military grade magnetometer compensation chip, and if you look around, it sounds like it's one that's it's a specific chip that is really good at. Let's see if I want to make sure this is the right one. Oh yeah, it's that RM3100 sensor right here, and supposedly it's able to reject noise, and it'd still be a very stable magnetometer sensor. Has anybody heard anything about this?
It sounds like you're volunteering to get one, and tell us about it, Doug.
No, I can't. But I'm just curious if anybody
Yeah,
else.
I vote. He gets one and tells us about it. That's what I vote to. That's what I heard.
No, it doesn't go that way. I was just wondering if anybody had run into that.
The only
You've got
thing
a
I
lot
can
of
say-
support for this endeavor. A lot of support here.
Yeah.
I just did a search on that, and there is a paper by Leonardo Regoli, Mark Moldwin, Matthew Pellioni, basically an academic paper that investigates that particular sensor. So if you
Can
do
you
a search on the sensor name, there's actually a paper about 6 links down that actually talks about an investigation into it. So
Murray, can you put that link in the chat?
unfortunately, I'm not. I can send it into the mailing list. It's on the other computer. Maybe I can find it again. I'll try.
What's the title?
The title is Investigation of a Low-Cost Magneto-Inductive Magnetometer for Space Science Applications. And the first name is Regoli, Regoli, Leonardo Regoli. And it's like, if you do a search on RM3100 magnetometer, it's down the list. It's about 6 links down, investigation of. You should see it.
ResearchGate.net.
No, it's DNB info. I've got the link here.
Oh, here it's the second one in my search term.
Here
There
we
it
go.
is.
Just pasting it in. I can get it there.
Doug, where did you run across that?
That company, let's see, what's the name of the company?
That was an Amazon link.
Yeah, that was an Amazon link, but the WIT Motion is it's a company in China that makes a lot of IMUs. If you recall, when I showed my plans for the year, I said I'm also looking at another IMU. Well, they make 6 degrees and 9 degrees IMUs and several other combinations of things. They have one with a GPS already built into it. So if you go on Amazon and look up at either this link or WIT Motion,
I just posted the link.
Okay, that'll you can find a whole bunch of things on that's by that vendor that look really interesting. I just have one of their 6 degrees of freedom modules that I was going to put on my test module as an alternative for the BNO 155, just to see how it did. They're not necessarily cheaper than a BNO, but they have a nice little box and it's kind of cute. But this caught my eye when I was looking at their product line. They put this in one of their what they call their military grade 9 degree of freedom IMU. So, and I believe that's in the one when they do the GPS, but I'm not sure about that. The GPS module with a 9 degree of freedom, if I recall, is about $129. So anyway, I wanted to try the 6 degree of freedom, see how it worked. I had a little buyer's remorse because I could have got for like $2 more. I could have gotten the one with their magnetometer, but I think I don't think it's that good of a magnetometer. I don't know. We'll find out.
It has worry-free support, though.
Yeah, they don't have a worry in the world. They got your money. No, actually, if you look at I think their reviews, apparently they are very good with their customer service. The reviews mention that over and over again. Now, I don't know if the guys over in China writing those reviews are saying that or just if it's real, but you know how it is. It is what it is.
Be happy.
Yeah.
Well, the one thing I got, it's an SPI device, and it has a lifetime friendly customer service and small noise. So I like the small noise part.
Yeah.
Small
noise.
Small noise. Yeah. It's all
15
relative.
nano NT, nano something. Anyway.
Nano Tesla?
Way beyond me on this one. Nano T's, whatever. And lowercase n, uppercase T. 15 nano somethings per at 200 cycle count. So, you know.
But I'm just saying, be interesting to see Yeah, I'd like to see that particular paper that Murray found. Maybe who
I
knows?
posted the link to it, Doug.
It's
It's
in
in,
the chat.
Okay,
in the
good.
chat.
See what
Cool.
it says. See what it says. Yeah. Because it would be not, we've seen, I know everybody here in the last 5 years has seen such an upgrade in sensors and things that were available to the hobbyists. So why not a magnetometer that's really, noise resistant? Could happen,
And it's military grade, which is cool. The next thing is to put weapons on your robot.
Which military is the question?
Yeah.
Yeah, and then you still have
You
to
know,
is the military grade enough to survive our own construction and use?
Yeah, well, military grade. I mean, I don't know exactly what that means because in the software world, they have this thing called bank grade encryption, which really means that they're just a bunch of buzzwords that somebody threw together, and it actually doesn't make any sense at all. It just makes it where there's a checkbox on somebody's list somewhere that, and then they don't really have a definition of what bank grade encryption is. So I'm wondering if this military grade thing has the same kind of deal. And yes, I'm being whole grumpy old man on this just because I've seen it enough times. So
Well,
often that just means that it's got the like temperature and shock ranges. So if it's talking purely about the hardware, it just might mean that it's got a bigger operating envelope than consumer grade stuff, which would be nice.
In the before time, when something was called mil spec, that really just meant that they went through all the regular parts and tested them. And the ones that fell within a narrow range. You can do that yourself if you go out and buy a couple dozen parts.
I don't know. I wouldn't agree with that all the time because when I was designing mil spec circuits for TI, I mean, there were specific specifications that an individual part would be rated against or designed for. It might be hermetically sealed packages. It might be temperature range. It might be susceptibility or resistance to radiation for space applications. So,
rad hard.
Yeah, but without any of the other stuff, to me, it's as everyone else is saying. It's just marketing mumbo jumbo. Doesn't mean squat until you look at what if any specs are really called out.
And considering this is a product from China, sold in China, it's not likely to be American mil spec. Could be the New Zealand military,
I don't know. China does have supersonic nuclear missiles now, and
hypersonic.
We don't.
Canada has 5 submarines, and 2 of them float.
Oh, damn.
Well, one of them won't float if you untie it.
The question is, can they not float? Or are they always floating?
We bought them from Britain. So one of them kept sinking, so they tied it to the dock. The other 3 were junk, and they got one that's running around, I don't know, in that bay in Halifax or something.
They take kids on board for $5.
That's right.
Exactly.
But it's mil spec, right?
Yep, 100%.
So
Right.
I probably don't want to start a whole new debate. But going back to some of the emails, so maybe it's just like a warning, a shot across the bow. I can maybe send something out to the list about a proposition that ballistic behaviors within specifically sort of David's definition. Isn't it likely that they can all be recast as servo behaviors with the right sensor construction, virtual sensor construction?
Yes. My answer is absolutely, and that it's not only right, but that it's preferable.
Right. Exactly.
Yes. Absolutely.
So there really is no need for the idea of a ballistic behavior.
Well, there are some places where you actually have to use them. You can't get by without it. But
like turning on a robot, yeah.
in the sense that you can get by without them, I would say that you should.
Well, even the the typical example is your bumper behavior, right? That's not a ballistic behavior, right? It's a bumper. The bumper initiates a. I would say you could, if you're reconstructing it as a servo behavior, the bumper is initiating a virtual sensor that gives a new target of a lapsed time or elapsed distance or elapsed loop count or whatever it is, and that opens up an escape behavior, right? So even there, you don't need a ballistic behavior.
No, I agree. I agree.
You'd have to explain that so I could understand it because I didn't get that.
Okay.
I feel a
Ballistic
bit dense at this
behaviors
point.
in the context of subsumption, bad.
I got that.
Bad.
Bad.
Reactive behaviors, servoing behaviors, good.
Okay, so let's pose a problem, which is the robot has bumped into something and we want it to back away from that and then go a different direction. Now, how would you do that without ballistic, as we've defined it?
You would initiate a virtual sensor that you've constructed that has that. I'm not trying to expand the nomenclature too much here, but you know, the objective-oriented or goal-oriented type of approach can be accomplished by simply constructing a virtual sensor that gives you a continuous signal up until the point where it has achieved what it thinks you're wanting to achieve, right? And so while you're executing on that virtual sensor, it is a regular servo behavior or reactive behavior.
So what is the potential states of this new servo virtual sensor?
Doug, let me try to simplify that if I can.
Yeah.
I agree with everything that Kareem just said.
Yeah.
I would use as an example, not a whole bumper behavior, but just the example I recently posted of a ballistic behavior that rotated through a certain angle. So that would be ballistic. You're told to go through an angle and don't stop until you have
Get to that, or you're interrupted.
So
yeah,
you're changing the topic, Doug.
Well, I'm just, you know.
Or you're interrupted doesn't belong here.
Yeah. So let's say we just
if you redid that instead as a servoing behavior, as Kareem suggested, instead of rotating through a certain angle,
yeah,
you would rotate to a given heading, irrespective of what the angle is.
Yeah, so sort of like a temporary waypoint then. Huh?
Yes. So that if you over rotated that heading, you would rotate back toward it.
Right.
Now, if you are subsumed during the course of that, it doesn't matter. But when the subsumption ends, you're still going, wherever you are, whatever position you're in, you're still going to try to rotate until you have that heading, not for a specific angle. The ballistic behavior would rotate through a specific angle, but the servoing behavior is seeking a specific heading. So, as Kareem suggests, the three behaviors that we normally associate with a bumper, which is to back up, rotate, and go forward, could all be recast as servo behaviors that are, in point of fact, reacting to the environment rather than just operating ballistically.
Yeah, well,
the problem with ballistic behaviors in the context of subsumption is that they can't really be subsumed. It breaks them when you subsume them. And that's why they are to be avoided if possible.
Yeah.
And I think that in previous discussions around this and in the mailing list, we've all kind of agreed that on some basic principles, like this idea that ballistic behaviors as defined could be interrupted, and that's a good thing. They need to be interrupted by whatever. So I don't think, and this is what I said in the email to Kareem, is I don't think that we really disagree, except maybe terminologically, about some of these things. But I still quite, because I had this idea of a macro, and the macro was triggered by a bumper, and then the macro would operate kind of in what I think you're saying, David, that it would try to make the robot change its behavior for a certain amount of time, but that certain amount of time now is then the ballistic time, and that's what I'm trying to avoid. But if we go to more of what Rudd's talking about with this idea of different goals, then what you would do is you would shift from the current goal, whatever that is, the generic goal, to a goal that says get away from this object. So for a certain amount of time, until we could find out that we were away from this object that we bumped into, we would change the goal, which would change the robot's overall behavior until that's finished, and then it would start up again into its normal mode. Is that quite close?
The only part of that I would object to is that in the context of subsumption, and I've learned that I have to begin all my sentences that way. In the context of subsumption, ballistic behaviors break when they're subsumed. So if you try to subsume one, the really only option is for it to abort.
And you made that point in the mail, and I think that's good. That's understood.
In the subsumption environment, when something is subsumed, it's not halted. It doesn't stop running. So when it stops being subsumed, it needs to be able to pick up from wherever it is, not from wherever it was. And because of this, as I say, that in my experience, if ballistic behaviors in a subsumption context are subsumed, their only real option is to abort.
Right. Agreed.
But otherwise, I don't disagree with what you said in the context of subsumption.
But we
that's subsumption.
And outside of the context of subsumption, we try not to even use those terms, right? So, and I'm talking again purely about my team, right?
But I don't disagree.
My program, yeah.
You don't really have a need for that definition because you guys are not doing subsumption.
Right. Yeah. But we still have goal-oriented behaviors that are either that can be self-terminating and might still need to be interrupted or suppressed. So we don't typically use the word subsume, but we might suppress one behavior from another behavior. And it's all constructed as state machines that aren't necessarily, there's still room for emergent behaviors. It's not like subsumption is the only way you can get to emergent behaviors. But because we're doing robots that are not just moving platforms, but they may have a shooter that has to independently, rotate. It may have a gripper mounted on the shooter that goes in and out. And like last year, we had an intake mechanism that could conflict with an external with a deployed gripper, right, where they could contact each other, right? We've got to think about we got to construct it as a bunch of subsystems that are potentially in conflict with each other, and we're just not bright enough to figure out how to do that with subsumption.
Bee trees.
Maybe.
Well, I'm actually really excited with Rudd bringing those ideas in because I've been, as you know, struggling around these edges because like every one of I've got a publish and subscribe model and there's events flying all over the place, and any behavior can either suppress or release an existing behavior or enable or disable. I've actually got both of those flags. And so suppression is basically a temporary thing, and disabled, usually when something's been disabled, it doesn't get enabled ever again until I turn the robot on, but or off and on again. But the idea of having some kind of a higher level control is where I've been struggling. And that's kind of where the ballistic thing comes in, because that's at the level of goal seeking. You're trying to do something very specific, like away from it, back away from something, or find a doorway, but those higher level, I've been kind of struggling for a paradigm of what that might be. And you don't really get that in the traditional, like the Brooks papers of subsumption. It's more like put a bunch of stuff together, turn on the robot and let it go. And there's not that idea of levels of behavior. And so I've been kind of trying to find my way, to something that I haven't found an easy definition of that I could implement.
Well,
So
I would ask you to drop the use of the term ballistic for that kind of thing, just to make it easy on all of us.
Well, I've learned my lesson.
I like goal or objective oriented, not object oriented, but objective oriented.
Goal is a great word. I'm going to use goal. I'm going to stay
Okay.
away from the B word from now on.
Well, and I think what Rudd suggested earlier today is something worth thinking about. That these are, in point of fact, what's the right word here? They're sub-units of a larger way of organizing things.
Yep.
Gentlemen, I have to bid you farewell this evening.
Likewise.
See you, David. And unless anyone else wants to jump in, I propose on that note, we call it a good night and crawl in our caves and wait till spring.
And I don't need to follow up on the list now. We have discussion on
Dave's
that.
an email. There you go.
No, we're good.
Old style email.
All right.
Good night, guys. Good day.